Faraday's laws of electrolysis. Who's Faraday? Michael Faraday was an English scientist and chemist who was born on September 22, 1791 and died on August 25, 1867. Carried out several experiments that substantially advanced our understanding of electromagnetic and electrolysis. What are Faraday's discoveries? His attendance at the public lectures of John Tatum was his entry to a world of scientists, and it was through Tatum he was presented to William Dance, who gave him tickets to the scientific lectures of Sir Humphry Davy. He discovered several new organic compounds, including benzene, and was the first to liquefy a permanent gas. Additionally, he popularized terminology like anode, cathode, electrode, and ion, as well as a first version of the Bunsen burner. And finally, which is our topic, the Faraday's laws of electrolysis. Michael Faraday was key improvement of the science of electrochemistry. Faraday's laws of electrolysis. First law. Definition. It states that the mass of substance deposited or liberated on an electrode during electrolysis is proportional to the total quantity of electric charge passing through the electrolyte. M is a direct proportionality Q, where m is the mass of the substance liberated or deposited on an electrode, grams, and Q is the total quantity of charge passing through the electrolyte, coulombs. Q equals IT. Therefore, m is a direct proportionality T. I, the intensity of the current, in ampere, and T, the time for which the current passes, in seconds, and or m equals zit, where Z is the constant of proportionality called electrochemical equivalent of a substance, and M is the amount of substance produced by the electrochemical reaction, precipitated, dissolved, evaporated or reducing, in grams. Electrolysis cell. As we see the electrolysis cell consisting, 2 pieces copper metal electrodes, copper sulfate solution, 0.5 m, and battery. Copper electrodes are inserted in copper sulfate. But before that, why do you think we have to wait the cathode before the current is passed? Since copper atoms are deposited on the cathode, the mass of cathode increases and the mass of anode decreases by an equal amount. The potential of cell is negative, which means it's non-spontaneous. The anode is positive and the cathode negative. The flow of the electrons in the external circuit, from anode to cathode, forms an electric current. Second law. According to Faraday's second law, if the same quantity of charge is passed through several electrolytes, the mass of the substance deposited or liberated at the electrodes is P to their chemical equivalent. M is proportional to E, where m is the mass of the substance deposited or liberated at electrodes and E is the chemical equivalent. If M1 and M2 are the masses deposited or liberated and D1, E2 are their chemical equivalents, M1 divided by M2 equals E1 divided by E2. Verification of Faraday's second law. The cathodes are cleaned, dried, weighed and then inserted in the respective cells. 2 electrolytic cells containing different electrolytes, copper sulfate solution and silver nitrate solution, are connected in series with a battery, resistance and an ammeter. Copper electrodes are inserted in copper sulfate and silver electrodes are inserted in silver nitrate. After that, the current will pass for some time. Then the cathodes are taken out, dried and weighed, MF. For copper, subtract M initial, from M final. Mi minus Mf equals M for Cu. And for silver, it is the same. Mi minus Mf equals M for Ag. It is found that M for Cu by M for Ag is equal to E for Cu by E for Ag, where E for Cu and E for Ag are the chemical equivalents of copper and silver respectively. Mcu divided by Mag equals Ecu divided by Eag. M is directly proportional to E, thus, the second law is verified. Applications of Faraday's laws of electrolysis. 1. Corrosion of metals. We observe that small pieces of the material are detached from the surface and become part of the solution side of the corrosion front. This process is similar to that observed in real experiments and named chunk effect. This effect can be one of the reasons for the deviations of the observed apparent weight loss of the corroding material from that predicted by Faraday's law. 2. Electrowinning. For example, copper electrowinning is the process of winning a high-purity copper from an aqueous pregnant liquor acid electrolyte in the presence of impurities. There are two upward flows in the cell, one is near the anode because of oxygen generation and the other is near the cathode due to depletion of copper ions from the electrolyte and buoyancy force. In the middle of the cell, the electrolyte recirculation zone causes a downward flow. Increasing electrical current density decreases copper concentration near the cathode and increases gas volume fraction near the anode, which is in accordance with Faraday's law. 3. Electroplating. The electroplating process, in which the current density distribution, generated using the finite element method, FEM, is used together with Faraday's law of electrolysis to determine the local plating depth. Plots of weight change of electrode versus current density shows that weight loss of anode and weight of deposits on cathodes are proportional to current density and plating time.